So, hi everyone, welcome to CaliFusion. CaliFusion is a decentralized platform built on the ICP and Calimero network designed to enable secure and privacy preserving machine learning across distributed datasets. Which basically means that it is a platform where various users can publish their models which they want that other users should come and train. But the users who will train the model, their dataset remains encrypted and private, and the dataset is not revealed, and nor are the weights and biases and the final parameters after training the model. And for in CaliFusion, we use the Calimero network as one of the primary uh, encryption tools, as well as Pedersen commitments, which is a semi-homomorphic encryption technique to let the data remain confidential. Now moving on to the tutorial, let us start. So I will get started here. So this is the app setup. The application ID I have already put, and so I have also put this one, but I don't this is a little bit UI problem. So let us set the values and now go to the login page. After going to the login page, it goes to the app setup. So it is page 2427. So I will set node URL as 2427. Then I will go to the ICP. Then I will try to authenticate the ICP one using the ICP wallet. I will use this connect, then continue. And as you guys can see, it will now open up. Yes, so it is now working, and from side the application ID, this one, and this is the context. So I will select the context and I will select this, and I will create a token. Now the token is complete, and now I am as the process is complete, now I will be redirected back to the dashboard, where there are two sections, as you can see, a publisher section as well as a trainer section. Publisher section: greetings fellow human. Obviously publish and share your model seamlessly here. So here a user can publish their model, and the user can upload any model of their choice here. So I will show you by uploading a new model. So you can choose any model of your choice. So you can even write your own model, import numpy and all the other libraries, or you can choose any file of your choice. Or like this is basically we support Python linear regression models currently, and this is a basic model that I have shown. So from here, this basic model is a linear regression model, and if I go to next, then they will ask for some metadata. I will use some metadata, and 01 and 0.01. So basically, after I click next, what will happen is, using the Diffie-Hellman key exchange, a key pair will be found. This key pair will then be used by me to encrypt the model. This model that I currently uploaded, it will be generated into a AES encrypted string, and this will be uploaded to the Calimero blockchain as well as the key, as the Calimero blockchain will act as an encryption layer. So both the private key and the encrypted model is uploaded to the Calimero network. And now if I click on the next button, you can see that the model has been updated in the draft section. So now it is currently in the draft section. If I want to publish it, I will have to move it to the publish section. So this UI part is basically called a Kanban board, which we have implemented for the users. So now as the model goes to the publish section, if a user wants to train on this model, the user has to do a payment of a certain amount of 0.01 ICRC1 tokens. And if the payment is successful, from the Calimero network, the model key and the model string will be given to the user, and the user will get a model in his model/model.py file in his client node. And from that, the user can, now the model training will automatically start from a run.sh script which we have written in the backend, and the model training will automatically start. And using the Pedersen commitments, the model will automatically models weights and biases will automatically be encrypted, and then they will also be sent to the Calimero network for aggregation of all the users values. And the Pedersen commitment is basically used to create a partial Byzantine fault tolerance. So I will be explaining a bit more to you about the architecture later. So let's go to the trainer section. You can see this is a hard coded value. This is the value I currently uploaded, 10th Feb. So you can see that if I go to the start training section and I go to choose file, I can choose any file. So let me search for a .csv file here. So if I choose a .csv file, it only supports a .csv file here. So this is a CSV file and I open it for my model, and the stake will be rebooted if the person does not pay the value. So that is, I think, so pretty obvious. So when I click on the stake button, you can see that the stake button I clicked upon, and after you can see that the stake button closed. So it was basically if we are successful. So you can see here, let me go to my console. This is some HTML hydration error. So this was basically creating a proposal. So this is basically the action transfer. The transfer happened to the receiver ID. This was the receiver ID. This is the raw response. This is the result. So the basically the transfer has happened, and as I can show you in my backend. So just a second. Yes, this is the backend. So earlier the payment was 452. So I think so now either it will be 552 or 652. I think so I had given it a try. So yes, it is 652 currently because I had done a trial also. So you can see that the account just was funded with 100 ICRC1 tokens. I need to normalize these values, so I will do so. And also in the backend that was running, you can see this was the server.js, and you can see this is the encryption cost. This is an encrypted cost. This is the salt is a random value used for the decrypt that are used for the Pedersen commitments, and this is the encrypted cost. Currently I am also printing X, but it cannot be printed. Like I'm just showing you the showing you how it will work. So here you can see that we get this from in our backend. Now moving on back to the publisher section, you can see that here is also one more button. If you go onto this button, you can see that from this address I received a payment, and this address has trained my model and sent it to the aggregator Calimero contract. And from there, if I click on the aggregate button, the aggregation on my contract will start. So the aggregation is basically a weighted federated average. So now if I click on the aggregate button, so the loss is 30.30, and you can see the salt and everything etc after decryption is also here. So it is basically it is a little fast currently because I just showed you it with one node, but if you add more nodes, it's a basic smart contract which will just take the weighted average. So now moving on, this is our wonderful git book. You can give it a try to read more about it. I will currently add a few more chapters here for the deep dive also, and you might also want to give this a look. This is a research paper by JP Morgan, which is one of my favorites, and the weighted average protocol was just inspired by this. We added a it is basically the about how the average protocol should be there for the federated learning part. And also now moving on to the architecture, this is a Excalibur figure that I had drawn, and I think so I had more explained more than enough for the architecture part, and these arrows and these directions will show you exactly how the architecture works. And so guys, this was all about our project, and hope you can also see about our user flow here. Hope you guys liked the app, and hope you guys and hoping to build upon it in the future. Thanks a lot. Thank you.